Hey guys, welcome to today's lesson. Today we're talking about dividing decimals by whole numbers. It's coming from 4.4 out of our book. And this should be a relatively quick lesson because we've been working really hard on long division. I'm really proud of the way you guys have worked so far. A couple of quick things to point out here while we're getting ready to start our lesson. This is obviously a typical long division problem, and I want to point out just a couple of vocabulary words that we're going to be using and seeing quite a bit in this lesson. This number that we have outside the house, this 10, the one that we say divided by and then a number, that's always known as our divisor. The number inside the house, the first number that we talk about, so we would say 62.4 divided by 10, the first number we talk about is known as the dividend. And our answer, of course, we learned long ago that that would be the quotient. So 6.24 would be our answer, or the quotient to this problem. So let's go ahead and get started. Today, our key concept, the main thing I want you to remember, is that when we divide whole decimals by whole numbers, all we need to do is place the decimal point in the quotient, so the decimal point in the answer, directly above the decimal point in the dividend. And what I mean by that is we need to look at where our decimal is in here and move it absolutely straight up into where our answer will be. So let's go ahead and try this problem. So if we look at this problem here, we have 14 divided by 8. Now remember, a whole number is really the same thing as 14.0. So we can just add that decimal point right in there. So 14 and 14.0 are the same thing. So what we want to do is we want to move that decimal point absolutely straight up. And now we're going to divide just like normal with 140 is what I'm going to pretend it is, and divide it by 8. So when we decide, we look through our division house here, and remember, Dad says divide, so we need to say how many times can 8 go into 14? How many times can we divide 8 into 14? It can only go in there one time before we have too many. Remember, we need to get it as many times as possible before we go over. So now Mom says multiply. I take 1 times 8, and I get 8. And then Sister says subtract. So I'm going to take 14 minus 8, and I get 6. Hopefully that's what you got. And then we're at Brother says bring down. So I'm going to go ahead and bring this 0 straight down. And so now I have 60. So how many times, now we start all over. Dad says divide. How many times can 8 fit into 60 without going over? Well, I know that 8 times 7 is 56. There's not enough room for any more in there. So 7 is going to be my next number. Mom says to multiply. I already said that 8 times 7 is 56. So I'm going to put that number down here. And then we're on to Sister says subtract. So 60 minus 56 would be 4. And Brother says bring down. Well, when we were doing remainders, we stopped when there were no more numbers. But now that we've moved on to decimals, we've got to keep adding zeros at the end. Remember, we can add zeros to the end of a decimal. It doesn't change how things are. So we're going to bring this straight down. And so now we have 40. How many times, start all the way up at the top, how many times can 8 divide into 40? Well, this is a good one. I know that 5 times 8 is exactly 40. So when I do multiply it out and subtract, 40 minus 40 is 0. When you get 0 as your answer and there's nothing more to bring down, then you're done. This number here, 1.75, is my quotient, and we call this a terminating decimal because it comes to an end. There wouldn't be anything other than zeros after this, so we call this a terminating decimal. All right, so let's move on, see what we got next. For example number 2, now we have 22.48 divided by 7. So we're going to go ahead, and our first step is to take this decimal point and move it straight up into where our quotient is. And now we're going to divide like normal. So we've got 7 and 2. We know 2 is not going to work, but 22 will. So my answer is going to go right above this last number that I used. So 7 can go into 22 3 times. Mom says multiply. 7 times 3 is 21. I'm going to subtract 22 minus 21. It gives me 1, and I bring down the 4. So now, start all over. 7 can go into 14 2 times. 2 times 7 is 14. 14 minus 14 is 0. Ooh, isn't that what I was looking for? Well, I can't, it doesn't count if I still have a number up here hanging out that I haven't used yet. So I've got to bring that 8 on down. And now I keep going. 7 can go into 8 one time. When I multiply it out, 8 minus 7 is 1. So I would keep going. Bring down my 0. 7 can go into 10 one time. 1 times 7 is 7. I get a 3. And oh, I'm getting way too far here, so I'm going to cut it off. We want to, unless our directions tell us otherwise, we want to cut it off and round it to the hundredths place, which means we need to go to the thousandths place to round it. So this 1 tells me that this is going to stay the same. So I would say this is, and I'm going to put this little symbol because it means approximately equal to, and that just lets you know that it has been cut off or rounded. So my answer is approximately 3.21. All right, so now that we said this means approximately equal, when you see a squiggly equal symbol, approximately equal, it just means that this is a shortened version. We don't want, sometimes our decimals can go on and on and on and on, and we don't want to be here all day doing them, so we round them. Here we have 12 divided by 9. Remember again when we have a whole number that we make it 0.0, so we have a decimal point there. We bring our decimal straight up and then we get going. 9 can go into 12 exactly one time. 1 times 9 is 9. 12 minus 9 is 3, and we bring down the 0. 9 can go into 30 3 times. 3 times 9 is 27, and 30 minus 27 is 3. Bring down another 0. I'm at 30. 9 can go into 30 3 times. 3 times 9 is 27. Oh, do you see a pattern forming here? Every time I get 30 and I subtract 27, I get 3 more, bring down another 0, I start with 30. This is a decimal that we call a repeating decimal. It's going to go on and on and on and on. It's going to be 1.33333333333333 and so on, all the way. So what we do when that happens, whenever anything repeating happens, when it starts to repeat, whatever repeats, we put this little bar over the top. We call it a Repetend bar. And that means the 3 keeps repeating. That I don't have to keep writing all those 3's, but when you see that bar over the top, whatever is underneath the bar is what repeats. So you have to be careful over what you put the bar over. We want to make sure we only get it over the number that's actually repeating. So this means 1.3333333333 and so on. So now here's 2 for you to try. Don't forget, the first thing you need to do is put the decimal straight up, and then you divide like normal. Good luck with these last 2 problems, and I'll see you in class tomorrow. Have a great night.